Okay, so Raquel and I will be presenting live-attenuated vaccines. And we'll start off with an introduction, a brief overview of how it works, limitations, methodology, and techniques, examples, the effect on the body, and advantages and disadvantages. So the oldest and most well-known method of vaccination is to use the whole disease-causing pathogen in a vaccine to produce an immune response similar to that seen in natural infection. Using the pathogen in its natural state would cause active disease and could potentially be dangerous to individuals receiving it, and it could also risk the spread of the disease to others. So to avoid this, modern vaccines use pathogens that have been altered. So how do they work? Live attenuated vaccines contain whole bacterium or viruses which have been weakened or altered or attenuated. So they create a protective immune response but do not cause the disease in healthy people. For most modern vaccines, this weakening is achieved through genetic modification of the pathogen, either as a naturally occurring phenomenon or in the lab, like modifications by scientists, and these live vaccines tend to create a strong and long-lasting immune response. So here's an image of how they work. So since these live vaccines are weakened generally in labs, the virus passed through many generations of cells to pick up genetic mutations that weaken it. So on the left, you see the harmful wild viral genome, and then as generations from left to right starts picking up mutations that weaken it, and you can see in the genome how it starts mutating it with the weakened mutations, and then that's how you get the weaker virus vaccine. So while they are strong and robust and a long-term immunity, in most healthy individuals, there is some cases where these vaccines may not be appropriate, specifically individuals with compromised immune systems, either due to chemotherapy, HIV, or primary disorders or immunodeficiency diseases. So these people should not be given live attenuated vaccines. And compared to inactivated vaccines, live attenuated vaccines also need to be carefully prepared, stored, and transported, and also administered. They normally need to be kept in a very cold temperature and may present challenge to more remote areas of the world that do not have the facilities to store and prepare and transport these how they should be. And I'll pass it on to Raquel.
Thank you, Karla. Okay, so now I'm just going to go a little bit more in depth on what Karla just covered. So as far as the methodology and technique, oh, sorry, can y'all hear me?
Yeah.
Can y'all? Oh, okay, I'm sorry. I heard something. I didn't know if y'all couldn't hear me. Okay, I apologize. So as far as the methodology and technique goes, for the live attenuated vaccines, it is almost about a 6-step process. So just to break it down further, again, the first step would be just collecting the wild viruses or bacteria, and those are attenuated by repeated passing in cell cultures or animal embryos. This could be chick embryos, for example, and this process does take about 10 years or longer. Just like the picture that Karla just depicted, it goes through that mutation and weakening process. And then the second step is transformation of the wild virus into the vaccine virus, which creates that live attenuated vaccine, which is then injected in small doses of vaccine virus or bacteria. So the creation of the actual vaccine, and then replication of this vaccine virus or bacteria within host to create that specific immune response. So induction of the immune response. And then, of course, the final step, which is creating protection against the real infection. Then next slide, please. Thank you. And then for those who are visual learners, as myself, this is just a breakdown of what we just discussed. So again, having that, excuse me, live attenuated vaccine injected. This could be orally or intradermally into the human body. These vaccine viruses enter the cells and they release the codes to replicate themselves. And in this process, the instructions are read within the human cell, and this creates more virus. But again, at this time, these are going to be a weaker version of the virus, or again, attenuated. And then they are going to be replicated, and they're going to be taken into the APC, cells. And then next slide. And then, of course, they are going to be, those APC cells are going to be displaying some of that viral protein, which is going to cause a threat to be detected by the body. So all these immune helper cells are triggered at this point, and then the body creates an army of B cells to produce antibodies against the virus, and those antibodies are going to bind to the virus to prevent entry into the cells. And then at this point, just like a lot of groups have already discussed, the threat is going to be cataloged or essentially memorized. So these memory cells are equipped in the real case of the virus attacking. So here, as it shows, immunity is created because these infected cells are now recognized and able to be destroyed. Thank you. And so as far as examples go, the live attenuated vaccine is broken down into two categories. So those are bacteria and viral. So for bacteria, we have BCG vaccine, which is also injected intradermally, just as shown as in the previous pictures before. Then we have typhoid, which is an oral vaccine. And then for our viral vaccines, we have oral polio vaccine. We also have measles, mumps, rubella, and then varicella, and then vaccinia virus. And then so to break these down a little bit further, the measles vaccine that's used today was actually isolated from a child with measles somewhere around 1950s. And again, that process took about 10 years of serial passage on tissue culture media, which were required from the wild type virus, or I'm sorry, not required. They were transformed from that wild virus into the vaccine virus. And then just as we learned in class, cowpox actually helped to create the vaccine for smallpox. So somewhere around the 1800s, when smallpox was an epidemic, the same time cowpox was happening in England from a lot of milk ladies who were working with cows, and they had a lot of little pox on their hands, so it looks just like smallpox. And these little pox created, or they were filled with fluid or pus. And so an English physician named Edwards Jenner, extracted this pus, and he actually injected that into live or healthy, normal patients just to use as a vaccine. And so that's how we got that live virus vaccine, and that actually created an immunity, even though it wasn't smallpox, it was cowpox. But since they have a similar makeup, it actually worked as a vaccine. So I thought that was pretty cool. And then, of course, for polio, it goes through the normal process of attenuation, and it was eradicated through an oral vaccine. And the last one that I thought was pretty interesting, BCG. So Microbacterium strain, was extracted, and this was put into a bile-containing media. And so this bacterium actually adapted to grow with a media that contained bile in it. So once it was actually injected into the body, it didn't grow, but it still signaled the presence of the virus for the immune system, just like you would want a vaccine to do. Thank you. And then for the effects that vaccines have on the body, a lot of these might be similar for the topics we're going over right now, but sore arm from an injection is very common, redness where it was given, fever, mild rashes, also swelling of the glands in the cheeks or the neck, and also temporary pain or stiffness in joints. Seizures are often associated with fever, so that could happen. More serious reactions include low platelet counts, which also cause bleeding and bruising. And then, of course, severe allergic reactions. And then in people with serious immune system problems, these vaccines could also cause a life-threatening infection. However, again, this usually only occurs with people who have a weakened immune system, as far as people who may be suffering from leukemia or even HIV. So again, like Karla and several of her have already mentioned, it is not a good idea and should not be done. So you should not be given vaccines to these patients, or live attenuated vaccines, excuse me. And this next diagram just breaks down live attenuated vaccines through different features. So as you can see, the first one says dose, so it's a low dose, and the efficacy is has good effects and it's long lasting. So it does have a good immune response, cellular and antibody, and it often provides lifelong immunity. And then as you can see, it says number of doses, single. So it's usually only one, sometimes two, but thus pretty much overall additional doses or booster shots are not usually needed. And then the shelf life is short. Safety is poor, just like we discussed earlier. They are technically a contraindication for people with impaired immunity. So it's not always the best solution. Stability is low. There's no need for adjuvant. And there's a revision of revulence could occur. And then duration of immunity again. So this is many years. So it lasts for a really long time. And then the last one, antibody response. So it's usually immunoglobulin G, which, as we all know, protects against bacterial and viral infections. And so here for our last slide, so is it an advantage or a disadvantage? So the advantages is it gives rise to a strong immune response, and then there's no need to booster dose, and then it's relatively inexpensive. So if you are a patient who happens to be in a developing country, this might be a very good option for you because it is efficient. Most of these patients are not going to be revisiting to take a booster dose. And then also it's affordable. As far as the disadvantages, there's always a chance of reinfection. And then there could be adverse side effects. So just any of the effects we also just discussed. So if the bacteria happens to skip the attenuating process or the weakening process, they may actually start to grow inside of the body after vaccination. And so instead of actually protecting at that point, they will be infecting. So again, there's good and bad. So it really depends on the patient if a live attenuated vaccine is good for you. And then here are our sources. And we could just leave that until we're ready.
Okay. Good.